Hello there. This is a recording of pages 232 through 234. Let's start with this page here. Complete the basic division facts. 10 divided by 5. So again, if division is confusing for you, try to think about it in reverse order and make it a multiplication problem. So this problem could be 5 times something equals 10. So 2. 5 times 2 is 10, so therefore 10 divided by 5 equals 2. 16 divided by 4 equals what? Think of 4 times something equals 16. 4 times 4 is 16, so 16 divided by 4 is 4. 18 divided by 2, 2 times something equals 18. 2 times 9 is 18, so 18 divided by 2 is 9. 35 divided by something equals 5. Flip it around. 5 times something equals 35. 5 times 7 is 35, so 35 divided by 7 is 5. 10 divided by 2 is not sure. If you're not sure, go 2 times something equals 10. 2 times 5 is 10, so 10 divided by 2 is 5. 28 divided by something is 7. 7 times something equals 28. 7 times 4 is 28, so 28 divided by 4 equals 7. I think that's it for that page. Let's look at this one here. Divisibility rules for 3 and 6. Tell whether the given numbers are divisible by 3 and 6. Write an X in the table to show that the given number is divisible by 3 and or 6. The table is completed for the first number, then complete problems 1 and 2. Alright, so this problem is divisible by 3 and it's divisible by 6. Well, what does that mean? Okay, so let's do this a little bit differently in 3. So if we count by 3s, we go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and we'll stop there. Actually, let's keep going because we need to go up to 51. So let's keep going and see how we do there. 30 plus 3 is 33. 36, 39, 42, 45, 48, 51. Okay, so 51. And now 6. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. Alright, I think that's enough. So 6 right here is divisible by 3 because you see 6 is a multiple of 3 and it's a multiple of 6. So therefore, we should have an X right here for 6 and for 3. Now let's check 12. Is 12 a multiple of 3? Yes. Is 12 a multiple of 6? Yes. Okay, now look for 15. Is 15 a multiple of 3? Yes, it is. Is 15 a multiple of 6? No, it is not. So, 15 is divisible by 3, but it is not divisible by 6. Let's check 21. So 15 is divisible by 3. Now let's check 21. Is 21 a multiple of 3? Let's try to find it on the list. Yes, it is. Is 21 a multiple of 6? No, it is not. So yes, 3, but not 6. Alright, check 24. 24 is a multiple of 3, and it's a multiple of 6. Yes and yes. And 51. Is 51 a multiple of 3? It is. Is it a multiple of 6? It is not. So, if it's divisible by 3, it could be an odd number. But it can't be an odd number and be divisible by 6. It has to be even. Give an example of a 4-digit number that is divisible by 3. Okay, let's think about a 4-digit number that might be divisible by 3. There's something here to look at too. When you are trying to figure out if 51 is divisible by 3, you can count up like we did over here. Counting up is just fine. But if you have to count up to a 4-digit number, that can take a lot of work, a lot of extra counting. So here's another way you can look at that. All of these numbers here that are divisible by 3, we saw them in our list and we counted. Okay, but there's another way to do this. You know 6 is divisible by 3, but let's say you didn't know that 12 was divisible by 3. So you do 1 plus 2, so you take 12, right? And then you put a plus sign in the middle, and that equals 3. And 3 is divisible by 3. Okay, so look at 15. 15, put a plus sign in the middle, 1 plus 5 equals 6. 6 is divisible by 3. Okay, so the rule is, if it can be divisible by 3, you add the digits, is the sum divisible by 3? Okay, so I want a 4-digit number, so go 1, 2, 3, and then 1 plus 1 plus 1 is 3, and 3 plus 3 is 6. So 1113 is divisible by 3, and let's check. 1113 divisible by 3. Yes, it is. Let's look at another example. What if we went 1, 0, 0? What number would we have to put right here to make a number that's divisible by 3? So look at the first digit. It's a 1. So 1 plus 2 equals 3. That would work. 1 plus 5 equals 6. That would work. 1 plus 8 equals 9. And that would work. So we could do 1002, 1005. We could also do 1009. Let's check 1002. 1002, is that divisible by 3? Yes, it is. Okay, cool. Now give an example of a 4-digit number that is divisible by 6. Okay, the rule for 6 and the rule for 3 are pretty similar. So add all the digits. Is it divisible by 3? Divisible. Okay, that's the first thing. That's the first rule for 6. And the second rule is, is it an even number? So a 4-digit number that is divisible by 6. So let's do 1, 0, 0. And look at this example again over here. Is this going to work? It's divisible by 3, but is it even? No, that one won't work. How about 1002? Will that work? It's divisible by 3. Okay, is it also even? Yes, it's even. So 1002 is divisible by 6, and let's check. 1002 divided by 6 equals 167. Okay, great. Let's do one more. A 4-digit number that is divisible by 6. Okay, let's do it. 9, 9, 7, and we have to pick another number that will work there. So we need to pick a digit here that will make it divisible by 3. 9 plus 9 is 18. 18 plus 7 is 25. 25 is not divisible by 3. But if you count by 3s, 24, 27. So if we have a 2 right here, then we have 18 plus 7 is 25, plus 2 is 27. 27, is that even? Nope, that's not going to work. So let's add 2 more. 9, 9, 7, 4. That way we get up to 30. I think, let's double check that. 9, 18, 25, 29. That's not divisible by 3. That won't work. Let's make that a 5. Nope, that's not going to work either because that won't be even. Alright. Let's move on from this problem. You know that it has to be 1 divisible by 3, and it has to be even to be divisible by 6. Finding area and perimeter of irregular shapes. Okay, so area and perimeter for each shape. So remember, perimeter is the outside. E-R. And area is the inside. E-A, area. So let's cut this. Let's find the area first. We know that's 9. And that's 4, and that's 4. So let's add 9 plus 4 plus 4. 4 plus 4 is 8. 8 plus 9 is 17, 18, 19, 20, 21. Area is 21. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Perimeter is 24. Units squared. And this is just units.